In the last lecture, we saw some basic concepts of set theory and some set theoretic operations as well. In this lecture, we will continue with that theme, and today we will talk about the second part, which is logic. So, what is mathematical logic? Mathematical logic, well, it's a structure with which you can decide whether things are true or false. Okay, so informally it is a structure with which one can decide whether certain statements are true or false. So here I am using the term statement. So let me try to informally again give what it means. So a statement, it is a sentence which is either true or false. Okay, so it is a particular kind of sentence. So not all sentences in the English language can be expressed as either true or false. For example, if you ask what is the day today, so that is not a statement which can be declared either true or false, but there are certain kinds of statements, sentences, which one can decide whether they are true or false. For example, today is Thursday. This is a kind of statement which can be either true or false, but notice that it cannot be true and false at the same time. So in mathematical logic, we always assume that sentences or statements cannot be both true and false simultaneously. Okay, so at the same time you cannot say that one sentence is true and false. Okay, so it can be either true or false, but not both. Okay, so in mathematical logic we restrict ourselves to statements which can be which are either true or false, but not both. In mathematics, a particular kind of statement is used very often, and these are known as if-then statements. So what are if-then statements? So these are of the form, these are statements of the form if P then Q. So where P and Q are statements. Okay, P and Q are statements. So this is a statement which is made up of other statements with these quantifiers. These are called quantifiers. If P then Q, it means this statement means that whenever P is true, then Q must be true. Okay, this is just a kind of a logical statement where you are given one statement P, and whenever that is true, then the other statement Q must also be true. So an example of such an if-then statement is as follows. So in day-to-day life, we can say that if today is Thursday, then tomorrow will be Friday. So this happens to be a true statement, okay, because Friday comes after Thursday. And whenever this holds, whenever the first part, this is our P here, and this part here is our Q. So whenever P holds, whenever today is the Thursday, then the part Q will hold, which means that tomorrow will be Friday. So these if-then statements are used in mathematical logic almost all the time, and so it's important to know what these mean. Now, what it does not mean is that if P is false, then Q is false. Okay, so we do not allow this kind of interpretation for the if-then statement. Okay, so we, as I said before, it only means that whenever P is true, then Q is true and nothing else. So if you say that when P is false, then Q is false, then this is a wrong interpretation of an if-then statement. Okay, so this is what it does not mean. So sometimes it's good to know what things mean, but it also is beneficial to know what they do not mean, right? So one has to see things from both sides. Okay, so another example, now a mathematical example, that if x square is positive, then x to the power 4 is positive. If x square is greater than 0, then x to the power 4 is greater than 0. And it so happens that this is a true statement. Okay, because well, if your square of a number is greater than 0, then the fourth power will also be greater than 0, and we will see a way to actually prove this, and I'll tell you what I mean by a proof. So once we discuss a little bit more about logic, then we can try to prove this statement. So these are just examples of if-then statements that show us how to interpret these kinds of statements, and we will see many more of these in this course. Notice that here it so happens that our first part P and our second part Q, if P is false, if it is false, meaning that x square is less than or equal to 0, then Q is also false. Okay, then x to the power 4 is also less than or equal to 0. But there are other statements where if our first part P is false, then Q can be either true or false. So just a note that if in an if-then statement, if P is false, then Q can be either true or false. So let me give an example where this happens. So suppose that you have two sets. So this is a mathematical example. So you have two sets A and B, and our statement is that if x belongs to A, then x belongs to B. So this is our the first part is P, and this is our Q, the second part. And so if you choose x to be here, if this is our x, then the first part is true, okay, but the second part is false. And if you choose x to be here, then both the first part and the second part are true. Okay. Now there is also another kind of an if-then statement, which is called a vacuously true statement, and this is also a logical structure or a statement of logic which is used very often in mathematics. And this is an if-then statement. So if P then Q, this statement is true if P never holds, okay, meaning that P is never true. In no case is P true. An example is the following. So if you write if a cat has 5 legs, well, let me write 50 legs, because 5 legs might still be possible. 50 legs, then it has 4 eyes, okay. Now the first part, if a cat has 50 legs, this part is our P, this is P, and this is Q, okay. And what happens here is that P is never true, okay, and we have never seen a cat with 50 legs, so P is never true. But in this case we hold that Q is true, and we hold that we take the statement to be true. This implies that this statement is true. So this kind of a statement is called a vacuously true statement, okay. Another such is that if x square is less than 0, then x equal to 0. So this part, our first part, P is never true, as we know. So square of a number is always greater than or equal to 0, and so this whole statement is vacuously true, okay? Vacuously true.